Hi guys, Mrs. Horner here. So I'm going to try to explain a little bit about solutions. It was explained in the lab background, but I'm going to do a little bit further. So we know qualitatively, if we look at solutions, we know that they contain both the solute and the solvent. The solute is the thing that gets dissolved. The solvent is the thing that does the dissolving. And in biology, we're going to focus on aqueous solutions where water is always going to be the solvent. But there's all kinds of solutions out there. Gas in a gas, gas in a liquid, gas in a solid, solid in a gas, solid in a liquid, solid in a solid. So for example, we're mostly familiar with solids and liquids where we have like salt, which is a solid, dissolving in a liquid such as water. But there are other things such as gases and liquids. That would be like soda because carbon dioxide is the gas dissolved in a liquid. There's things like solids and solids, which are a lot of your alloys like pewter and 14 karat gold, all kinds of solutions out there. So that's enough about solutions, but what we want to focus on is how to quantify these solutions. Like when we're measuring these solutions, how do we quantify them? And there's three ways. You can do it by volume, mass, or by moles. Volume is something that we usually only see in like alcoholic beverages. It'll say like a proof, and that's usually by volume, how much alcohol to how much other substances are in there. We're not going to use that in biology at all. But mass is going to be our biggest one. And of course, moles is going to be one too. When it's mass, we usually say they're like percent mass, okay? And it's basically the mass of the solute per the mass of the solution times 100. And we'll see how to calculate them below. And moles is moles of the solute per 1 liter of the solution. So let's get to how do we like figure these out. By mass is easy. You almost want to look at what it says. If it says the percent of, like if it says 15% of a solution, it's always the solute that they're talking about, that percent. So for example, if they say we have an aqueous solution, it's a 15% aqueous solution of salt and water, the 15 goes with the salt. So that means the water is 85% in this case. And then it's real simple to convert it. You just convert the percents directly to grams, okay? So if it says it's a 15% solution, then that means you have 15 grams of salt in it. And then the rest would be water, and that's 85 grams. And remember that 1 gram of water is equal to 1 milliliter. So how would you make this solution? You'd measure out 15 grams on a balance, then measure out 85 milliliters of water and simply mix them together. That's how you're going to do your by mass, your percent composition like solutions. Okay, so that's the first type. The other type takes a little bit more. And we first have to look at some conversion factors. Okay, so remember I had taught you about moles, molar mass, right? We know the molar mass of something equals, like if we add up all the atomic masses. So 1 mole of substance equals its molar mass in grams. If that substance is an atom, you just go with the atomic mass. If its substance is a compound, then you're going to have to add up and figure out the formula mass. Another conversion factor that we're going to need when figuring out molar solutions is 1 liter equals 1,000 milliliters. Easy so far, okay? But then we get to this value here, molarity, which is represented with like a capital M here. Molarity equals moles of the solute. So if we're talking about a salt and water solution, moles of the solute would be moles of sodium chloride per 1 liter of solution. Remember, the solution is the sodium chloride and the water combined. Okay, so these are 3 types of conversion factors that we're going to need when figuring out molar solutions. Okay, so now let's just get diving right in and take a look at one of the problems here that we have. So the question is, how do you make 50 milliliters of a 0.25 molar calcium chloride solution? Okay, so you want to make 50 milliliters. That's your given. 50 milliliters is your given. So you're going to start with 50 milliliters of the solution, 50 milliliters of solution. Okay, and you want to get to finding out how many grams of that calcium chloride do you need to put into this solution. So we do a little factor labeling here. Okay, and if I can boost this up a little bit. We'll check this out. Okay, so 50 milliliters. Well, first we got to convert that to liters because we're going to want to use this molar conversion factor, but we're going to use it in moles per liters. So first we got to convert that milliliters to liters. Then we can use the molar conversion, 1 liter on the bottom, 0.25 moles of the calcium chloride on the top. So we're converting the solution to just the calcium chloride, which is a solute. But then that's in moles. We still have to figure it out in grams. Oh, so my light went out here for a second. Hold on. Okay, light's back on here. Sorry about that. The automatic light went off. Okay, so what do we have to do here? Well, we have to convert those moles to grams. Where did I get this 111.1? Okay, well, that's the molar mass of calcium chloride. When I add up 1 calcium plus 2 chlorines, it adds up to 111.1 grams. Okay, that converts to grams. And so our answer here, this 1.39 grams of calcium chloride, that's how many grams we're going to have to add into our little volumetric flask. And a volumetric flask is a cute little item that you're going to put mass out, 1.39 grams of calcium chloride. And these volumetric flasks, they kind of look like they have like a bulb at the end. I would hold up one right now, but I don't have one here with me. They have a long neck, and then they have like a bulb at the end, right? Okay, and then they have a line like about here on the neck. You're going to put that 1.39 grams into that volumetric flask. Then you're going to add water until it fills up to that line. Okay, so you add this. You don't have to measure out the water. It will measure it out automatically for you, but you want to dissolve a little bit. So you add a little bit of water, shake it around a little bit, get it dissolving a little bit, add a little bit more water. Don't go over. If you go over, you got to start all over again. Okay, so you must use, and this is what I mean, must use a volumetric flask. That's one of these doodads, okay, to do this. But you also have to do this whole factor label thing to figure out how many grams you even need to put into that. So again, easy peasy when it's like percent composition. The percent is the grams of the salt, and then the water is the remaining grams to equal to 100. But when it comes to molarity, you got to do a little conversion, little factor label to figure out how many grams you're putting in that volumetric flask, and then fill it up with water the rest of the way. Okay, so this is explained in your lab, in the background information for the lab, but this was just another explanation for you, and I hope this helps everything. Okay, let me stop sharing that screen.